Good afternoon, everyone. I'm going to tell you a little bit about the WaveSub wave energy converter. I've presented before at Marine Energy Pembrokeshire, but we haven't really said too much about our device, so a lot of you, this will be the first time you've really seen some detail of the device. The format of my presentation will be, I'll initially give you a little bit of an overview of the WaveSub and the challenges that it solves in wave energy. I'll talk then a little bit more about the energy capture of the machine. That's a key feature of the WaveSub. I'll give you a quick update on the quarter-scale project, and I'll talk a little bit about our future plans. So the challenges of wave energy, I think these challenges is the reason that wave energy is a little bit behind tidal energy. It's probably a little bit more difficult to get wave energy right, and we identified in the early days of marine power systems that we really had to deal with the challenges of energy capture. The energy in waves is actually a subsurface orbital energy flow. It's a little bit more tricky to access. The survivability is really important. It's a very harsh environment in storms where the wave resource is good, the storms are also good. So you have to know how to deal with that. Transportation, operation, maintenance, very important. Wave farms are likely to be quite a long way offshore. That has to be a relatively straightforward process. Nothing offshore is all that straightforward, but so we've seen it important to make it as straightforward as possible. And of course, the capital costs are important. You have to be able to do all that at a price that's sensible so that you repay the cost and make some money for the project developers. So we think that most existing devices that have currently been developed or are in development don't really meet these challenges, but we're confident that the WaveSub does. So just to relate that to what we all want, which is a sensible cost of energy, the challenges I spoke about aren't a sort of esoteric, nice-to-have set of challenges to solve. They actually really are the core of the problem here. So you can see there I've just identified where these challenges actually crop up in the cost of energy. So things like survivability, well, actually that costs you because you have to engineer a heavier structure and you have to over-engineer your moorings, etc. So you can go through the whole lot and you'll find that if you don't deal with them, the device and the power it produces will just cost more. So how do we solve this? The first one is dealing with the energy capture. We have a very efficient orbiting energy capture mechanism. Secondly, we have a unique variable depth mechanism for the WaveSub. The WaveSub is adjustable in depth. It can float on the surface like a barge when it's being deployed, making it very easy. But also it can descend beneath storms and actually adjust itself to be in exactly the right position in the water column to capture the optimum energy. And it's also a simple design. There's a little bit of, we've decided that it's worth having the extra functionality in the device to adjust the depth, but ultimately it's a fairly straightforward thing to fabricate. And because we can survive storms where we actually shelter the device from the storms, we don't see the loads in the first place, we can reduce the fabrication costs. So I said I'd talk a little bit about the energy capture. This slide just sort of gives a quick overview of what's important for energy capture from wave devices. It's a little bit more complicated than, say, for a tidal device or a wind device, where your main consideration is just to point it into the flow. So for a wave device, you have to think about the reaction, motional freedom. Can your device actually orbit rather than just capturing heave or surge? Can you adjust the working stroke? Have you got sufficient working stroke? Can you adjust the mass and the spring rate to tune to the wave period? How do you damp the device? The bandwidth that gives you in combination with other things, can you tune it to all the different sea states you get? So all of those things are really important, all things that we've considered from the outset with the WaveSub, and if you get those things right, then you get good overall energy capture. So just a couple of points with the WaveSub here, showing you a video of some tank testing that we recently did, and this shows the orbital energy capture of the WaveSub. You can see there the reactor sitting relatively stationary below the surface, and the float orbiting in the maximum wave energy, and the relative movement between the two yields excellent energy capture. Okay, so another aspect of the device I spoke about is the variable depth and geometry. So the first thing we can do is we can vary the float depth, so the actual depth of the float from the surface. And to simplify this, what we say is that we adjust the float depth according to the wave size. So if the waves are small, we put the float right on the surface where all the energy is, or the most of the energy is. And as the waves get bigger, if we start to exceed the rated power of the machine, we gradually take the float deeper in the water until in a storm we can take the float and the reactor right down underneath the water, 50 meters below the sea, where obviously the loads are going to be an awful lot less than on the surface. And the other thing we can do is we can independently adjust the float to reactor distance, and this allows us to tune to wave period. This is, for those of you that know the importance of this in waves. This is really key, and this is a unique and patented mechanism that we've covered in pretty much every relevant territory. So we're very proud of our technology and the unique features it has. Just to put that in a little bit more context, so this is, at this stage, this is an animation of our simulations. It's the easiest. We have replicated this in the tank, but this is the clearest way to show it. You can see there we have two scenarios that we're dealing here with short period irregular waves. And by bringing the reactor close to the float, we get a 30% increase in power from a nominal deeper reactor. I'll move on. And if we turn it around, if we then swap the configurations in a more regular long period sea state, and we deepen the reactor and increase the distance between the float and the reactor, then we get a 25% increase in energy capture. So you can see this is absolutely, these are big numbers. If you think back to that cost of energy equation, 30% or 25% more power isn't to be sniffed at. It makes a huge difference to the overall cost of energy. So now I'll just talk about a little bit more about where we are as a company in our quarter-scale project. So we're right in the middle of, or actually we're nearing the end of the manufacturing process. The device is being manufactured at Ledwood Mechanical Engineering down in Pembroke Dock. You can see there in that first picture on the left, you can see the reactor frame, which is now complete, and there's some buoyancy tanks there that are coming from Camplas fiberglass in Bridgend. So again, utilising the local Welsh supply chain a lot here. Here we can see some other components that are finished and ready to begin assembly. A little bit less Welsh content here. The main float again is coming from Camplas in Bridgend, but the winch and the associated systems are coming from Aberdeen, and unfortunately we didn't even find the best supplier we found for the cylinders was actually a German company, but you can see most of the device is Welsh stroke UK. Another very important part of the system is the control system. We've invested a lot in getting this right and having a really comprehensive control system for the wave sub. You can see here we have full real-time telemetry on the wave sub. We can monitor from the shore everything the device is doing in real time. All of our key systems are readable from shore. All the sensor readouts, the position in the water, the attitude, altitude, angle, movement of the device, all we can see on a graphical user interface from shore in real time. So the next thing we're going to do is test the quarter-scale prototype this summer. The first stage will be a sea trial in Milford Haven. We're not intending to generate energy here. We're intending to prove that the sort of underlying functionality of the wave sub works, so that we will be essentially commissioning it, doing some tow trials, variable depth testing, that kind of thing. When that's complete, and hopefully, fingers crossed, that's successful, we'll be transporting the device, towing it down to Fab Test near Falmouth, where we'll be doing 6 months to a year of long-term testing and generating energy, and hopefully proving all of our, and validating all of our tank and computational simulations. So going forward from that, as soon as we've got some favourable data from our quarter-scale prototype, we'll embark on our full-scale demonstrator project. It'll be a multi-megawatt device in the region of 3 to 5 megawatts. It'll be grid connected. We'll supply energy to the grid, and we hopefully will be generating some reasonable revenue from the device. And from all of the significant groundwork that we've done over the past few years, we anticipate that with minor changes, we'll be able to commercialize an exact copy or exact copies of that device. So we'll be ready to actually build out, hopefully, a small farm in the Pembrokeshire Wave Demonstration Zone shortly afterwards. Going forward, we think Wales is a fantastic place to be based. It's got a great position, sort of halfway across the western seaboard of Europe. We can export north to Scotland and Ireland, and export south to France and Spain and Portugal. The key USP of one of the key USPs of the wave sub is that it can be transported easily. So that is great for setting up a centralized manufacturing base. We don't have to decentralize our manufacturing. We really can build a big, significant manufacturing center in Wales. The kind of things we're expecting by 2020, we hope to be building out our first farm, so that would be a turnover in around the tens of millions. But by 2030, we would hope to have a turnover in the hundreds of millions, and probably a workforce in the hundreds as well. And we're excited to be heading towards that. But of course, we have to successfully complete the testing of our quarter-scale prototype first. Okay, that's it from me. Thank you for listening. I think we're doing questions at the end, so I'll look forward to any questions at the end of the talk. Thank you.